will be joining. Everyone else who's joining in will be logging in as attendees. So they will be perhaps asking questions on the chat, which I will moderate and share with you. And I am Dr. Anupama Sanjeev. I will be your moderator for the occasion. I work at Atria University. So let's just dive right in. Now, all who are present here are very eager to hear from both of you about your journey in energy sciences. I'll start with Professor Mitra. Where did it begin, and where do you see it going?
Okay, so I started my journey at Bombay 2009. So from that time itself, I started journey on the energy storage. I work on the energy storage, mainly on batteries. What I see that now, I think we are very much on the energy conscious and efficiently we are using energy. But our demand is increasing because our industrialization is increasing. Then our demand is a human demand is also increasing. And another sector is just transport, keep on increasing the vehicles number. So that obviously it is again related to the energy. So some kind of energy is converting and going for a mechanical energy conversion. So keep on increasing. So we are, I am at least enjoying this sector because many demands, whatever students we are graduating from my lab, getting good position, like a position in industry, even academia. So that means the field is very much smooth right now and is growing exponentially. That's my looking at it.
Thank you, Professor Mitra. Mr. Rahul?
Yeah, thank you, Anupama. Basically, I am engineer, mechanical engineer. During my master's from Michigan and Ann Arbor, I started working in robotics and controls engineering. So I think I will qualify more as systems engineer across multiple disciplines. I have worked across mechanical, electrical, electronics, computer science, now automotives. And during those robotics time, I was working on developing a hexapod and how to control battery, how to drive the movements and all other things. So that's where the first introduction of energy with engineering combined came. And since then, I think I became a systems engineer more on the engineering and energy side. I was then working in automotives, heading R&D for a German company based out of Detroit, Bayer Hella. So we were looking into a lot of air conditioning in automotives. Again, it was an energy problem to solve, like how do you control it for best end customer use, but how do you optimize the consumption, the fuel consumption for air conditioning. And since then, I think then I returned back and started heading a private equity with ICICI Ventures Foundation. And that was where I started looking into the rural energy problems, like how do we solve energy access problems using different technologies. I was looking into all kind of technologies, gasifications, RE, energy efficiency, their applications for livelihoods, as well as energy consumptive use. And I think that's when I kind of struck me more strongly that while we may continue working on generation technologies with more renewables, but our consumption has to become energy efficient. Our distribution has to become energy efficient. And that was time of 2010, 29 to 2009. And that was the start of my journey to start looking into the distribution systems and figuring out like what are the inefficiencies in our systems. And then my early career at pManifold was quite a bit involved in terms of looking into those root causes, then starting to work on public-private partnerships model in power distribution side to fix those issues. I was lucky to be part of different PPPs, the first of its kind in the country in multi-PPPs on city level power distribution PPP models. And that was actually the genesis of pManifold. We worked on first of the 50 megawatt solar thermal power plant that is the first operating plant in Jodhpur today, concentrated solar thermals, lot of work in solar PVs. And I think similar to journey of Dr. Mitra, then I got involved, luckily, to be mentored by Professor Ashok Jhunjhunwala at IIT Madras. And that's how, with all his journey of low voltage DC, DC solarizations, and then transport acting as a subset of broader DC energy efficiency, I got involved with him on e-mobility. And now I think it is almost 8+ years now that we are working across e-mobility projects in 42 countries. So I think, yes, energy and systems have become very much part of thinking and living, Anupama.
Thank you. That was very interesting to hear from you. And like you mentioned, since you've had extensive experience in mobility projects, I'm going to dive right in and talk to you about, also you also have worked on energy policy to some extent, which I will ask you more about it. There is phase 1 of the National Green Hydrogen Mission, which is already started. So how do you think has been the response from the different MSMEs, from industry, and given your policy input as well and your experience in mobility, what would you say?
Sure, sure. I think India is acting well. Globally, if you will look, Anupama, and for the broad audience, primarily 3 areas where we are trying to decarbonize the world. Like one is the renewable energy, which is the most extensive contributions coming from. Second is electrification. So whatever we are able to electrify, including transport, electric vehicles, and also a lot of industrial heating processes. So that's the second big bucket of electrification. And the third bucket is actually hydrogen. And this bucket is expected to contribute close to 20% of the GHG mitigation that can come for our climate goals. So I think that is the importance of hydrogen. And I think India did well following its electric mobility mission. It came up with also simultaneously national greenhouse mission, green hydrogen mission. And I am actually in Delhi attending a fairly well organized conference by MNRE and Ministry of Power and Petroleums. And this is first time after e-mobility that government has organized all the stakeholders globally to really push for national green hydrogen momentum. In terms of next steps from policy, I think many a times you have an ambition, but you kind of get slowed down by actions, by actual regulations and actually industry development. This time, actually, our government has done quite well now. Like very recently, this week, only they announced 2 incentive schemes as well as part of the National Green Hydrogen Mission, like how to actionalize the mission. And these 2 schemes, one is looking into providing subsidy for electrolyzer manufacturing, and another is looking to provide a subsidy in terms of rupees per kg for green hydrogen produced. So it has it's kind of acting both on the demand and supply side subsidies. I would say that the subsidies are small, but I think it's a good kind of signal to the industry that government is keen and it is taking directions. And parallel to national vision, I think there are many states and they are only getting added with their state level green hydrogen policies. So I think the momentum is kind of coming together. I could see a lot of excitements between different stakeholders, Anupama.
Yeah, it's also it's a big coincidence, I think, that like you mentioned, the international conference is on. So you can get a kind of first-hand feel of the response from there. So thank you for that input. Professor Mitra, what do you think? What is the response from academia and research institutions regarding the national mission?
Yeah. So one thing what I see right now, this hydrogen technology or hydrogen production is not dependent on the availability of resources. It is like a water is available. But if you look at it, any other technology where we need something which is not there in our country. So apart from only technology, which is technology is the one which if you can develop by anyone, like industry, academia, collaboration or academics, how to convert this water to hydrogen, like electrolyzer way and more efficient way, then it will be it will not be dependent on anything. So it is the only one what I see is independent of resource. Like it is completely will make it really Atmanirbhar, what is going on right now, and that way to form one form of energy. But many other things are there which is complicated, which is not easy. But if you look at it theoretically, let's say 40 kilowatt hour of energy required to form a 1 kg of hydrogen. Industry is required right now. These are theoretical values, but right now is 50 kilowatt hour of energy required for 1 kg. And if you convert into that energy required and the cost, so it is quite high. So this is a big opportunity for academicians to reduce that and make it more efficient. That's I think challenge we have to take it anyway.
So it's both opportunity for both
And
academia, yeah, and complexity. There are several layers of complexity because, like, as we progress in the conversation further, we'll also talk about the challenges that India will face, which brings us right into the next question. Now, I think France is leading with respect to production of green hydrogen. So India has just begun. So relatively, India is taking baby steps. So do you think, Mr. Rahul, I'll address this to you first. Do you think there are certain essential steps that India needs to take, or if they have already been addressed in the green mission that has been put forward by the government?
Sure. That's a good point, Anupama. I think not just France, but overall European Union, I think they are fairly progressive in terms of the green hydrogen. And I think the seriousness towards it has only increased. And you will see a lot of momentum in last close to 2 years because of current geopolitics scenario that European Union is with Russia and Ukraine war and hit on their energy supply chain. So there is a extreme focus on independence and energy security, and less focus currently on the economics part of it, right? So their need for energy is driving them towards going for green hydrogen as a source independent of fossil fuel. That's what we have seen much momentum. In terms of capacities of electrolyzer, if you will see, I think Europe would have some close to 200 megawatt electrolyzers capacity already operational, while China would have some lower than that, I think 50 or 80 megawatts. And this is growing at a double speed. India, I think we have, yes, you are right, like we have taken a baby step, but I think we should not forget, Anupama, that fairly we are on the same page with the world now. The kind of technology and everything that has started being developed and being thought over with policy mechanisms, including infrastructure. So I think India is fairly at a reasonable level, I would say, compared to the developed world. This is the key difference. Like I keep hearing from many people, and Dr. Sagar Mitra can give more details, like India has missed the bus of solar manufacturing indigenization, right? Lithium batteries also, like there are doubts like whether we would really catch up with the efficiencies and economies of China. But I think in terms of overall green hydrogen value chain, because everyone is on similar page, early part of learning, experimentations and scale up. So I think if we really put our acts together and make it work, I think it can really create a very good opportunity for India to be ahead on technology side and also become an exporter of technology, not just exporter of green hydrogen, but also exporter of technology to the other part of the world. And as part of your second question, like how does our National Green Hydrogen Mission is addressing this opportunity? So I think it's a timely mission. I think it was enacted in 2021, but in January 2023 now, it has also got cabinet approval of some close to 20,000 crores Indian rupees. And out of which the two incentive mechanisms I was saying, Anupama, like the one on electrolyzer manufacturing, something close to 4,000 crores, and almost another 13,000 crores is towards the green hydrogen production subsidy. So this two mechanisms, which are clearly defined mechanisms of disbursing of those subsidies, are also in place. However, like they will come into enact from 25 to 30 time period, 5 years time period. So I think what is important for India is to really not lose this 2 years. To be really very sharp in this 2 years, that we are able to identify very clear use cases across the value chain. And with those clear use cases, doing the pilots, doing the R&D, drawing our learning of economics and benchmarking with the right prices, internal and global competitiveness, and then be ready for the scale up that is coming forward. So I think this is one of the key area that I think we should remain focused. And I think the mission has already started working, and my company is part of it. We are supporting MNRE, supported through GIZ, where we are looking into green hydrogen standards across the value chain. So we have benchmarked developed worlds like European Union, US and Japan, fair progressive, and their standards, certifications, regulations. And we have done a first level of study like what India needs to do in terms of also parallelly having its standards in place while the industry is kind of developing bottom up. So I think that piece is also kind of coming together. And a little bit, I think that will anyway come. That those are the steps that are getting discussed during this conference as well. How do we create demand, right? So these subsidy schemes are creating demand, but how do we push it? So I think the next step would be something kind of a mandates on the industry. So very similar like the big and heavy industry already has energy efficiency mandate through PAT scheme, performance, achieve and trade. I think something similar are likely to evolve also for green hydrogen. There are some industries like refinery, fertilizer productions, steel, cement, which uses heavy hydrogen, right? Either as a feedstock or a diffusing agent or by heating process. So I think there this hydrogen is currently being generated using fossil, either natural gas or coal. I think that's where the first early opportunities would be to convert them into green. So I think creating those use cases, creating a right mandate, getting the pilots moving to draw the learnings, I think we are very much will be ready for scalability.
Thank you, Mr. Rahul. And so, Professor Mitra, the 2-year time that Mr. Rahul mentioned. So where do you see industry, academia, research pitching in to make this journey?
Yeah, so this 2 year is very crucial for us because we are in a baseline right now. So we need to scale up this our productions. Again, if you think about green hydrogen, so green hydrogen means you're producing hydrogen from green source of electricity. That means renewable electricity. So that means we have to increase the renewable electricity again in the double space. Again, you will be dependent on some other country where you are getting the silicon modules or silicon solar cells. So it is not actually fitting in the whatever we are thinking. Unless until we produce our own silicon panels, it is again we are dependent on some other countries. So you can increase this size, but again you have to increase the other side also to produce. See, it is meaningless if you have a fossil fuel burning and then using that electricity and producing electrolyzer, hydrogen electrolyzer. So efficiency doesn't. As engineer, I don't think we'll have the efficiency calculation fits on that. So we need to work on that. It's not easy. So that means we need to work on much faster scale in R&D. Even industry also look at it, how to minimize. You cannot avoid this situation, but how to optimize that so that I have a less dependency, but I have produced more hydrogen. So what he's talking about industrial uses, doesn't need a green hydrogens. What I believe. So green hydrogen for other purpose. So so in that sense, maybe you can utilize the mix match of mixing of different sources and produce hydrogen for any other quality, and then use for let's say cement industry, steel industry is one of the industry which uses very high amount of hydrogen, where green hydrogen may not be the particular requirement. So that's the way you should look at it. So I feel a lot of optimization study has to be done to optimize the all sides. That's the way I think.
So it's not an easy solution by all means. There are layers
When
to it,
next 10 years, we don't have easy solutions.
and there are also connections which go back to other
Again,
kinds
is
of energy.
actually burdening.
Yes. So yes, I know it will not get resolved in this webinar, but it's a good forum to start talking about
Thinking,
these
the
issues.
thinking.
Yes. Yeah. So I'll move to the next question, which again is related to the challenges. Now, if it is, especially if it is to be considered as fuel in the mobility sector, there are some very specific challenges in terms of low production efficiency, then the safety concerns also. Now, sustaining all this in the long run for manufacturers, given these challenges can be difficult. You also spoke about subsidies, so I'll touch on that. The USA is already offering a subsidy of, I think, $3 per kg. Would subsidies work in India the way we are and the way we function? Would it be sustainable? Mr. Rahul.
So
Yes.
first part of the question is, if I understand, Anupama, is around hydrogen application to mobility, right? Now, what is the alternative that we are comparing hydrogen application, right? So it's the current diesel versus pure electric versus now the hydrogen. So these are the three options that we are looking at. Within hydrogen, now there are two main kind of solutions. One is the hydrogen ice, where you are still combusting hydrogen in an engine with air, and the other one is the fuel cell driven thing, right? So the way the need of hydrogen to mobility is coming is for the heavy duty mobility applications, for example, trucks, right? Now, we have done extensive work. We have developed India's first zero emission trucking medium heavy duty roadmap as well. And it's a public document. So if any of the audience would be happy, like I can direct them to that report. And what we identified is like when you apply pure electrics to higher duty trucks, right, you will require heavy batteries. And the battery's energy density at the moment are still fairly low. And what that mean in terms of weight is that the weight will be quite high. And this weight will then kind of create limitations of the payload. The payload, the purpose of truck very much is kind of getting jeopardized. So either you figure out a en route charging where you keep small batteries, but you charge them fast across the route. So that is one option. Or the other alternative option, which is being explored and fairly large amount deployed in heavy trucks, is the fuel cell driven trucking applications, where now you are using a higher energy density form of hydrogen in tanks. You run it through a fuel cell. You convert it into electricity. You will still need a battery, but now the battery has been almost 1/3 of its original size in applications. So the battery size reduces, and then you run the application. So what this combination of battery and hydrogen stored on board allows you is to do a longer range in a straight shot. So now whatever diesel was able to do for a one straight 900 kilometers, let's say from my city Nagpur to Mumbai, now we are having hydrogen as an option to be able to do that, right? Now, is this viable today compared to the diesel option? Not, right? The economies of scale, the infrastructure for hydrogen, they are not developed. But theoretically, if you will start looking into the use cases which are having a need of long runs on daily basis, then the parity of hydrogen starts coming closer. So I think that is a challenge the world is now attempting to solve. While economics is the base effort to drive, But I think the more driver for heavy duty trucking and hydrogen applications is coming more from the decarbonization perspective. But with all the economies like the batteries falling down, the green hydrogen cost is also expected to come down. It is expected that some of these applications and use cases specifically will start becoming more and more viable. So that's the first part of the question, that yes, there are efforts being made to decarbonize mobility applications, more so using battery electric vehicles. Dr. Mitra can talk more. He's a world expert in that space. And in heavy duty applications, including shipping, green hydrogen is being now looked at. Like for shipping application, now it is being explored that can we just directly use the ammonia for combustion, right? So those kind of turbines are being explored very early stage, some pilots on deployment, where we can run long distance shipping with ammonia. So rather than converting ammonia to hydrogen again, right? So it is being thought that can we run it directly? So those are also the applications that are being looked into the mobility. Your second part of question regarding subsidy will work. I think any form of subsidies is good for the early market development phase, right? And we have seen the effect of right level of subsidies going into RE and kind of that leading to the early market development since 2011. And now we have fairly high, almost 26% RE capacity in our grid today. And we are targeting 50% by 2030. So I think this early market subsidies in hydrogen in different formats will be really useful. Central has come up with two kind of subsidies, as I said. On supply side, electrolyzer manufacturing subsidy. On demand side, some 50 rupees per kg of hydrogen subsidy that will also taper down in next 5 years. So these two subsidies, like we did some calculations on cost of hydrogen per kg, leveraging with and without this subsidy. So typically in today's cost, a green hydrogen production in India, I am kind of using an example of a 1 megawatt electrolyzer, right? Using, let's say, PEM, which has higher efficiency. Like we are talking of close to 430 or 450 rupees per kg, which is greater than $4, right? Around 4.5 US dollars per kg of hydrogen. If you combine these two incentive mechanisms put together, then we are talking of it coming little closer under 400. So it's still only kind of less than $1 kind of a optimization that happens, but it is still greater than $3.5. US by its need to really stand taller across the world, and its reduces dependence, has taken a little bigger leap of $3 subsidy versus ours is, I think, comparative 55 rupees per kg is around 0.65, right? So our $0.65 per kg versus US giving $3 per kg subsidy. This is different companies are taking different bets depending on their ambitions and geopolitical influence of energy on them, and taking call on subsidies. But yes, early subsidies will help the market development. Even states are now augmenting. In addition to central, lot of states now they are augmenting different kind of exemptions, land price exemptions, electricity duty exemptions, the RE that is coming through the interstate or intrastate transmission and distribution to your site. Those surcharges are being exempted or reduced. Water charges are being reduced. So there are multiple kind of things which kind of adds up central plus state kind of incentives to hydrogen production. So I think all these things will help us take the next steps rightly, Arupam.
Thank you, Mr. Rahul. That was a very lucid explanation for someone like me who's actually not in the world of energy sciences. I understood it quite well. So I'm assuming everyone else would appreciate it far more, those who are in energy sciences. So Professor Mitra, your input to this.
In the transport?
Yeah.
Yeah, so hydrogen in transport is, from my thinking, is a little bit complicated, because hydrogen right now, maybe India is thinking to blend with any existing fuels and not any fuel cells. because once you have a fuel cells, then you have to have a hydrogen fueling stations, and that is a technically absurd things right now for the infrastructure wise, because we cannot make even battery charging station throughout India. And complications is that hydrogen fueling station will be much more complicated in terms of safety. So various kind of safety levels are required for hydrogen stations. So that may be the longer vision of India, I believe. But mixing of hydrogen with any existing fuel could be looked at it. So you need to change maybe many technical points of the transport. Obviously, to do for the truck, I think truck already the committee report from the PSS office already talked about battery plus hydrogen in the fuel cells. So we need to look at it, how we can mix it with the existing fuels, hydrogen, some proportions, and then make it feasible for at least for a few years time, unless until we have our infrastructure of hydrogen fuels station is done. Which is a complicated, even in US also not done anything on that. So in that sense, India may take longer time for fuel cell driven vehicles. It will take some time, as per my opinion, technical way.
Thank you, Professor Mitra.
To add a little bit to what Sagar ji told, I think I see two kind of good complementing forces that will act, which will push both the technologies. One are our oil giants, right? The Reliance, the Adanis, and others, IOCLs and others, whose business is based on fossil. Now it is changing to alternative fuels. And I think they have enough muscles also to drive the right architecture and right infrastructure, right? Be it generation, port shippings, pipelines for gas blending or the new. So I do believe that 10, 15 years from today, this big agencies will be driving the hydrogenization of the economy, including refueling systems and stations, right? Because that's very much part of their business, what they have been doing, right? So that will happen. And another force will be now working on the electrification and charging infrastructure creation. And these forces, I tend to believe, will be our big PSUs like NTPC, PGCIL, and other agencies who will kind of take lead in terms of setting up this national highways infrastructure, charging infrastructure, city level charging infrastructure. So I do believe that we have this good institutions and forces, both government, public, and also private, which can drive these two parallel things together. So I do believe that this will be coexisting technologies, and the developments will kind of go little hand in hand.
Thank you, Mr. Rahul. At this point, I'd just like to tell everyone else on the webinar that if you have questions, please share them on the chat. We are, as we come towards the end, we have about 3 or 4 more questions that we will have as part of the conversation. If you have additional questions, please share them on the chat. We will share it with the panelists after we are done with this round of questioning. So continuing on the challenges front, transport is also a major challenge, transport of hydrogen itself. So how would you look at it, Professor Mitra?
Is another technically challenging area. So you need to gaseous form right now. Mostly people are looking at it, a very high pressure. And there is technically there is a ortho-para transitions. Anyway, it is actually complicated. And you need to maintain some temperature. So transport of gaseous hydrogen, even liquid hydrogen, is a complicated issue. And you know that hydrogen reacts with everything. Is a star, even steel also reacts with hydrogen. So that is a major issue right now. How you transport from one side to other side. And once it is complicated, so it will be cost associated with that. And how you handle and how these things will be looked at, it maybe whoever is thinking, planning for like larger distributions, they may have a plan, but it's not that easy. And the technical person, I see that much more complicated compared to any other things to transport from one side to other side. Even lithium-ion batteries also transport. It's go through a regulatory system. Like it's not that easy to transport from one side to other side. Even aeroplane doesn't take the batteries, like a battery pack. So you have to go by ship. The hydrogen is much more complicated in that sense. So more complication means more cost associated with that. So that will increase again the cost of for the users. So that also need to look at it. So many technical problems are there.
What do you say, Mr. Rahul?
See, like for every problems, I start seeing opportunities. So I agree with Dr. Mitra that there are challenges. But I think there are a lot of agencies and there are commercial solutions which are already existing. And with more economy of scale, I think that will start coming down. Just to understand what are the solutions we are talking, like we are talking of gaseous hydrogen being shared, being transferred using pipelines. I think that is supposedly the most economical options compared to a lot of other options. It has its challenges. Now doing this over a completely new green line project of new pipeline being laid down, or doing it in an existing pipeline which is already built, carrying our compressed natural gas and doing right kind of blending. So I think blending is being looked upon as a good option, but I think there are technicalities which are being looked upon from safety. Hydrogen molecule is odorless. It can penetrate into the steel structures. So all those safety issues, and especially in your pipelines with bends, valves and everything, there are already mechanical strains in the pipelines, and they become more kind of open for the leakage. So I think those are the issues that are being kind of resolved, but pipeline is definitely an important element that is being looked into. Then second is the tankers, right? You have stationary tankers or you have mobile tankers. Mobile tankers going on the roads or seas or rails, all those remains as an option. In liquid, I think we are talking of what Sir said is like, right, like we compress it and we take it to a temperature of minus 250 degrees Celsius. And that's where we need more cryogenic coolers to keep and maintaining that temperature when the long distance shipping is happening, right? But it gives you more weight, right? The energy density increases when you convert it into liquid. So typically for long distance thing, you will convert gas into liquid, and then that higher density liquid is being transferred, right? But you need to keep the cooling. So either you do some passive form of cooling or more active kind of cooling to maintain that time temperature, depending how long you want to transfer. So I think these two solutions, I think, are more ready solutions, relatively more matured. Now taking it to commercial scales across all the economics is, I think, what is kind of getting worked on today on the storage side.
So a lot of interesting possibilities on the horizon. Hopefully they will come very soon.
Many technical challenges, many possibilities.
I see Kartika and Vikram have raised a hand. Would you want to ask a question, Kartika? Hazel, can you unmute Kartika?
Yeah, please.
Hello, sir. Thank you for this. I want to ask only one question, sir, because you explained about electrolyzers, right? Because nowadays, in some of the industry, they are focusing on electrolyzer, but cost is very high because we are using platinum only, Nafion solution, everything is so costly. We are getting from outside only. Instead of getting that, because that is green hydrogen, that's why we are doing that one. Why we can't focus white hydrogen? Because that is why, because in the hydrogen we have so many types, right? Some of the hydrogen it's creating pollution, so we can't consider that. If we are focusing on white hydrogen, that is very cheap, we are getting naturally, right? Why we are not focusing on that?
Remind me, there are just too many hydrogen colors, right? So white,
Yes, sir.
white hydrogen.
White
is,
hydrogen.
what
Black
is white
hydrogen.
hydrogen? Can you remind me, like, what is white hydrogen?
White hydrogen mean hydrogen we are getting naturally from the earth. Like see the earth crust. What are the,
Hydrogen is not available freely. Hydrogen need to be produced.
I think like white hydrogen is what we are talking is captured as a byproduct of industrial processes. Yeah, so there are a lot of processes like chlorination and other parts where hydrogen is actually getting produced as a byproduct. So they are saying that anyway you have to do that process, but just hydrogen is coming and then you use it, right? So you still have a limitation of how much the main product that you want to drive. So I don't think it's a scalable model to kind of base. So I think that's why the world is looking into green, but I think the world is going little crazier, even frenzied by their worry about the carbon part in the entire process, right? Like Europe, Japan, UK and Japan are further stringent, like how much CO2 emission per kg of hydrogen they will allow and classify as green. So definitions of anything ranging from 2 to 4 kgs of CO2 per kg of hydrogen produced. So I think that is creating a lot of complications. Like I was into this conference last 2 days, a lot of people are asking what green and other things. I am hoping that India keeps it simple. And if I have to just give you as an example of a Shimla apple, right? The red apple, right? So the cities have simple apples, local regional apples versus a costly big size red apple, which is coming from Shimla, right? As a user, you have an option to choose what apple you want to eat, right? And this Shimla big apples would have a sticker, kind of a certification that it has come from Shimla under some conditions. And if it has to be exported, then it has to be having a further sticker, which says that how it is done and blah, 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 and then done. And if it is organically produced, then it will have a different sticker, right? So I think that we should not worry too much about this different stickers. The fundamental molecule of hydrogen is remaining the same, right? Which is apple, right? Now there are flavors of it. Let all flavors coexist, right? So if I'm doing business in India, I will sell my hydrogen produced, right? And if I have to do business with European Union and there's a higher regulation and compliance to it, I will follow their certification standards and I will get that premium, right? So it's basically, I think we should stay away from a lot of confusions and focus on the basic fundamentals. So I think the green hydrogen is a right way. But I think we should also look into how do we make our gray hydrogen blue and from blue to green. So those pathways also should be parallelly kind of supported by developments. Like gray will not become green immediately in a day, right? But if that gray kind of going is a slower path, then can we make gray more economic? So that's where I'm a very strong believer of carbon capture technology. I think that is a segment where unfortunately not much has happened and it is in very early stage. So again, that's an opportunity. And I think maybe Dr. Sagar Mitra can add upon it, sir, but I think driving attention on carbon capture technologies, making it commercially, including the direct air carbon capture, DAC, I think that will be very good if we can really develop it and commercialize it. So yeah, so blue hydrogen, which is using carbon capture technology, how we can improve it and then continue progressing to green. So both pathways, I think we should kind of explore, making existing gray blue and making, of course, new green. So these are the two pathways I think as India we can focus.
Professor Mitra, you want to add to that?
Yeah. So what is saying white, I think that amount of byproduct, what he's saying, the same thing, is so low from the main, it is not a main product, it's a byproduct. So the amount will be a few percentage out of the total productions. So that cannot survive, it means that cannot serve for the main purpose. That's why people are not looking at much. But is it freely available and you can use it anyway for smaller applications. But other thing is what is a very interesting thing, like it's carbon dioxide capture and utilization for useful chemicals. Last few days back, I was in a DST pad I see that hydrogen production, more than 40% project was on the hydrogen production, and even more than 40% project was on uh, carbon dioxide capture. It is all the projects on these two. So that shows that it is academia side also taking it as a challenge and then try to solve it. The main thing what I see is that technically it is efficient, less efficient, because any process you do to converting to something from carbon dioxide to something, any carbon like ethanol, methanol, or any propylene, anything. If you have to make it out of it, you need to have again energy input on that, and that energy again coming from another carbon dioxide and is very poor. So we should look at it without any energy requirement, like any natural conversion is possible or not. But thermodynamically, that the activation energy is barrier is quite high. That's why it requires some extra energy to be put in. But obviously, this is another scientific challenge could be looked at it, and I'm sure many projects will come and will be sanctioned from the government of India in these two sectors.
Thank you. Kartika, I think you got a very detailed answer for your question. So I just want to mention that we are at 12:58. Is it okay to continue for another 10 minutes, Mr. Rahul? Because we started a little bit late. Would that be all right?
Sure. Let's try to wrap it up in 10 minutes.
Yeah. All right. Thank you. So moving on to the next question. Now, within India, different governments have started allocating money. Like, for example, the government of Maharashtra has allocated something like 8,562 crores. I got this from the report to implement their policy on green hydrogen. Now, there are two parts to the question. Would this add to the overall national mission outlay, or is this separate from that? And then would each state need to look at it separately then?
Sure. I think like you have a very sharp research eyes, Anupama, because this Maharashtra example and numbers you gave is very, very recent. Like only this week, they took it to financial cabinet for approval. I was speaking to some seniors there who are looking for some support going forward. But yes, I think point one, like the state budget is separate outside central budget. So this will only augment and add upon to the national budget of close to 20,000 crores. So I think that is a good news for the players to kind of leverage different state economics to make their venture or enterprise more profitable. And each state typically will have its own jurisdiction, its own thinking, its own constraints. So I think there are already 4, 5, or 6 states who have come up with their policies, including Rajasthan, Andhra Pradesh, Tamil Nadu, Odisha, Gujarat. So I think they all have little similar ways, but in terms of numbers and other supports, depending on states, will vary to vary. So yes, I think like it went into electric mobility, each state coming up with its own policy. In RE, each state has its own policy and jurisdictions. So I think similarly in green hydrogen, I would expect that from different peer learning, but each state will have its own kind of green hydrogen policy.
Professor Mitra, you mentioned that DST now many projects are being related to hydrogen and carbon capture and so on. So do you think for research and academia, it would make sense to have something starting from a state level also?
Yeah, but this is centralized from the central government. Even state government also funding some of the demonstration projects. If you are, because they are not funding the basic science, but if you have some concept and that need to be taken up in a slightly bigger scale to show out in the demo to the industry, state government, even Maharashtra government also funding that. That much I know. So yeah, that is a interaction with the government, local government also the institution. So they are also looking at any technologies coming up.
Okay. So I'm just moving on to the next question. This is about the Atria group. So we are, the Atria group has been in the renewable sector for a while now, and it has had some experience. So I'm asking both of you, what do you think would be a strategy for the Atria group to contribute, first of all, to the policy framework, which is, I think, still evolving with respect to green hydrogen and energy, and pilot projects. And third, and perhaps most relevant to much of the audience here, the skilling both faculty and students. Professor Mitra, would you like to go first?
Yeah, I believe from academicians wise, you should have an open thinking. You should not have a structured thinking. Think about technology development, new technology. It's not that what is existing and we are bringing it from outside. You should think new technology, could be demonstration level, even for a small scale level, but think about new things. That's my way of thinking. Because if you are not thinking new, industry cannot think also new, because they don't have less R&D, because mostly they have less manpower on the R&D sector. So you should think, you give a concept in a smaller scale, so the industry, if they like, they'll take it in a further. This is the two sectors, at least renewable energy plus the storage and conversion right now is actually a bigger opportunity. Many opportunities are coming. The students should, even student faculty should come in and then contribute. Other one is, you are saying that the training part, I can always say that support also that any academicians, like any faculty here, should have a understanding what industry wants. Okay, there should be some kind of workshop or something should be make available from the industry, at least energy sector, people who are in the front line, so they can tell you what are the things they are facing problems. Okay, all technologies are not available, so they have to do some kind of bridging. So what are the things they are facing in the field, that should be known by the faculty, so that they should orient themselves in the curriculum and then try to address that. That's my way of thinking.
Mr. Rahul?
See, like this morning only, I was trying to learn more about Atria Group, its portfolio, its power sector. I think I found some interesting things, like you already have some 500 megawatt plus RE assets, mostly wind, but also solar and hybrids in south and central states. But you also do a lot of demand management and consulting services also in that space. So in addition to your own portfolio, you also do trading of power and services. So I think first for Atria Power, I think it can look into leveraging its RE portfolio and seeing like how with further investments on the green hydrogen production side, it can get better returns. So for your $1 already invested in RE, and let's say your another $1 invested in green hydrogen production. So between this investment versus RE only and RE plus electrolyzer production, which is giving higher ROI, right? So I think on right case basis, I think that I see as a simple extension for Atria Power unit to kind of start leveraging its RE unit. So I think that is kind of answer to what Atria can immediately do. In short time, I agree. In mid time, I will agree with Professor Mitra that look for new things, right? Like one, you already have an EPC portfolio, so you can build similar EPC portfolio also in green hydrogen and the entire value chain and its derivatives. So that is very easier extension. But you can also look into technology developments, given the group size and more than $2 billion assets. I think you can very well look into investing in startups doing right technology developments and taking it into even manufacturing, right? So that part also Atria can explore as part of its further expansion into the part. And in terms of skilling side, I think I'm already quite super impressed with India's current pedagogy, and I am very happy that India has such institutions who are brave enough to challenge the pedagogy style, right? And Just for everyone to know, like pManifold is also supporting Atria University in developing a BTech program in EVs and also delivering that program jointly. So that is my exposure to Atria University, and having something like which I would have wanted when I have learned engineering. I see Atria now executing it, right? Like you don't have to worry about those 5 or 7 courses all at the same time and giving exams. You very spend time, focus on one course, complete it, take all exams, everything, then do the other course. So I think these are very applied ways of learning and really learning it more physically and experientially. So I think you are already doing good. So I think now extending that, you have already extended to e-mobility and a lot of other industry relevant courses, as Dr. Sagar Mitra was saying. I think now you can start doing similar in green hydrogen part. Like and I think it's very early. Even very few IITs have only started thinking and doing some experiments and trying to garner a center of excellence in green hydrogen. So I think Atria can very well take a lead to kind of set up a center of excellence in green hydrogen, start supporting courses for its faculty, students, even external learners, start doing projects, start supporting entrepreneurs within your so big student ecosystem, some 2000 or 3000 plus, and start doing consulting services, right? And possibly leveraging some of these things for your Atria power. So I think you have a good ecosystem to kind of leverage internally on the skilling side.
Thank you. And with support like from both of you, I think the ecosystem will evolve enough to keep up with the changes and the advances and whatever is happening on the science horizon. I think Sami Rahman, he's an associate professor with us in energy sciences, had a question. Hazel, could you unmute Sami?
Sami, I've unmuted you.
Hello, am I audible?
Yes,
Yeah.
Sami.
Yeah, good afternoon. Hello, everyone. So my simple question is, will be there any social or environmental concern which may arise during this transition from battery to hydrogen technology in the transportation sector?
Sure. So I think it is like any other project, Sami, like whenever you set up any industrial plant, right, it will displace the land, right? So there are social issues associated with it. And those displacement of lands, handling the diversity of plants, animals, people around it. So it will also have environmental points. So I think from that angle, green hydrogen transition will be fairly similar. That for a new kind of a plant and infrastructure that will set up, so we need to handle the social and environmental and associated issues. And I think world is getting more and more, I would say, like exposed and learned about the handling these issues. In fact, the new certification measures which are being getting discussed is not just about the RE and other part, but also having the social and environmental indicators inbuilt into the certification. So if you are generating green hydrogen and you are generating in a right, just way of social and environmental and other concerns, the trading certificate given to the hydrogen produced will have a higher value in some markets, right? So yes, there are points which are getting looked into, and the life cycle assessments from the environmental and GHG emission perspectives are being more and more closely watched. In green hydrogen, there will be a lot of export markets, right? Like there is a good demand that is coming from these countries, and they are paying premium for green hydrogen. So I think some of the early cases, which is building estimate or bringing attractiveness in private players, is to start exporting this produced green hydrogen. So I think those will also drive those sustainability criteria for setting up the new plants.
So, sir, there are multi-millions of investment has already been made in e-vehicles right now. many entrepreneurs are already there into the business. So how do you think that these transition will going to impact these entrepreneurs in coming 5 to 10 years? They will be accepting it, or there will be a denial? Means what can be the probable scenario?
Sure. So I think they are not, they are kind of complementing Sami. Like, I don't see a challenge like in electric vehicle space. If we talk a two-wheeler, three-wheeler, four-wheeler will continue to be walking that pathway of electric. Yes, there are some who will start working on fuel cells, also on the smaller vehicle segments. But I think those are early segments. So I think I will agree to Dr. Mitra that uh, uh, pure electrics is a far superior technology as applied to transport applications, right? With the current maturity that we have developed in the overall supply systems. Green hydrogen applications will come. Some players will put bets on that and they will start working on that technology. However, it seems to have a more higher application focus on the industry use cases, which are called hard to abate sectors, where electrification may not be the best solution. And that's where green hydrogen is kind of coming in. So I think there will be enough of both market segments and specific use cases where entrepreneurs can remain focused and work on their course. Maybe Dr. Mitra can
Yeah,
also.
I have also same opinion because I don't think battery-driven vehicle will go off immediately because the fuel cell-based vehicles will take some time because that needs a lot of infrastructure. Also, the maturity is not matched with what battery vehicles can give. So in that terms, I don't think it will be immediately transferred. So that maybe it will transfer, but slowly, not fully.
Sure. And just to add to that, Dr. Mitra's point, see, electrification is not about battery, right? Electrification is more about replacing engine with a motor, right? And motor needs electricity to run, right? And now you generate this electricity using a lithium battery, or you are generating this electricity using a fuel cell. But even if you use the fuel cell, you are still requiring the battery. The battery does not go away. Its size kind of reduces. So you will see that most part of your electric vehicle is still remaining. It's only the battery size is kind of reducing and a hydrogen tank is getting added and an electrolyzer, a fuel cell is getting added right now. So that's why this addition takes space and weight, and hence the fuel cell technology has more applications to more higher and big size vehicles, which can accommodate this weight and space. So that's why trucking, shipping, those are more first applications of deploying hydrogen in mobility.
Thank you, Mr. Rahul. This has been a truly very, very engaging discussion, and I'm sorry we overshot time. It's 1:15 now. So even if there are questions, we will probably share them with you on email and have a conversation beyond this webinar. Thank you. Thank you very much for your time, Professor Mitra and Mr. Rahul. It would have been great to have you here in person. I hope that happens sometime. As a parting shot, what would be the few words of advice that you would give to our students? What not to miss and what to look out for?
I think Professor Mitra is more closer to students, so he can take the first shot on it. While I'm thinking.
I'm also thinking what should be the one-liner. A student should be open-minded and see the what trend is going on in the industry as well as in the science field or science and technology field. So they should be open and act on it.
Yeah. I also support that point because I come from systems background. I keep talking across different streams of engineering and non-engineering learners that we should help our students build systems thinking and systems design perspective. And what is system design? Like different kind of streams are interacting And most times you will find that problems is at those interactions. It is an engineering system, or even if it's a non-engineering kind of an organization, or even political systems, typically issues will always arise at the interfaces of two departments working with each other, right? Or two motors and batteries working with each other, or an IoT based wireless system working with the electronics and with onboard system. So typically the problem and solutions lies at the interface. So I will encourage students and also faculties to kind of start applying more and more systems thinking and teaching and practicing. So I think that will definitely improve the quality of your learnings and your retention of the knowledge and taking it to the real world. And I think as I said, like Atria is already doing a very strong style of pedagogy. I just hope that you really leverage and learn best out of it, and kind of improve your career forward. So my best wishes to all of you.
Thank you, Mr. Rahul. Thank you. And we hope to meet you in person sometime.
Thank
Thank
you.
you,
Thank you.
Professor Mitra.
Sure. Thank you, Dr. Mitra. Thank you, Anupama. Thank you, everyone. Good
Have a
day.
good
Bye. Bye.
So he's in Nagpur or Delhi?
No, he's in Delhi.
Lastly, today's